In this question, they have asked to evaluate sigma I from 0 to infinity, j from 0 to infinity, and k from 0 to infinity 1 by 3 to the power I into 3 to the power j into 3 to the power k. But one condition they have imposed is that I is not equals to j is not equals to k. इस क्वेश्चन का मतलब क्या हुआ देखो. The question is pretty simple. They have asked for the summation of all the terms which is in the series in which your I is not equals to j is not equals to k. So you have to find out the sum of those terms in the series in which your I is not equals to j and not equals to k. Is it clear? तो ये सम को करे कैसे? ओके, एक चीज देखो, अगर ये सम में कोई कंडीशन नहीं होता, if there is no condition in this question, it means that whatever terms that we have in this series, you are finding out the sum of all those terms, right? Here there is no conditions imposed. जितना भी टर्म्स है सबका एडिशन तुम्हारा क्या होगा या सम कितना होगा, ये हम निकालने का पहला कोशिश कर रहे हैं. मतलब क्या बोल रहे हैं देखो, if suppose let us denote this thing by s, this one as s, and now my s with no restriction. नो रेस्ट्रिक्शन मतलब इस सीरीज में जितना भी टर्म्स है सबका समेशन हम निकाल रहे हैं. सो इन दैट केस वी कैन राइट दिस थिंग एज आई जे के आर 3 इंडिपेंडेंट वेरिएबल. सो वी कैन राइट दिस थिंग एज सिग्मा I from 0 to infinity 1 by 3 to the power I, k is from 0 to infinity 1 by 3 to the power j, sorry this is j, and k is from 0 to infinity 1 by 3 to the power k, right? So सिर्फ इसका सम हम निकालेंगे because the other two sums इसके लिए और इसके लिए exactly same होगा. So what is the sum of this? Sigma 3 to the power k, इसका मतलब है if I start from 0, it is going to have 1 plus 1 by 3 plus 1 by 3 square, 1 by 3 cube, and this thing goes on till infinity. So this is actually infinite GP series, so I am applying the sum formula, which is your A divided by 1 minus R. So it is coming like 2/3, it means 3 by 2, right? Therefore, the sum of the given series when there is no restriction, in that case तुम्हारा आंसर कितना आएगा? इसके लिए भी 3 by 2 होगा, ये भी 3 by 2 होगा और ये तो 3 by 2 है, हम लोग देख लिया. मतलब total sum will be 3 by 2 whole cube, which is 27 over 8, right? ये जो 27 over 8 जो समेशन आया, ये एक्चुअली है क्या? इस सीरीज में जितना टर्म्स है सब टर्म्स का एडिशन इज नथिंग बट 27 over 8. अभी थोड़ा ध्यान लगा के देखो, ये जो मेरा विदाउट रेस्ट्रिक्शन सम आया है, क्या क्या पॉसिबिलिटीज है? What are the terms in different conditions involved in this series? Number 1, यहां पर ऐसा हो सकता है, ऐसा बहुत टर्म्स है जहां पर I is equals to j is equals to k. ऐसा बहुत सारा टर्म्स है जहां पर I is equals to j not equals to k. ऐसा बहुत टर्म्स है जहां पर I is not equals to K is equals to J. ऐसा भी बहुत टर्म्स है जहां पर I is not equals to J equals to K, right? और एक तरीका का और टर्म्स है which is I is not equals to J is not equals to K. So these are the 5 possibilities. These are the 5 different terms under different conditions जिसको सबको अगर हम ऐड करें तो I am going to get the sum for this series which I got it as 27/8. लेकिन मुझे उस टर्म्स का सम निकालना है, ध्यान लगा के देखो, उस टर्म्स का सम निकालना है जहां पर I is not equals to J is not equals to K है. इसका मतलब ये हुआ अगर हम ये टोटल सम से ऐसा जितना टर्म्स है उस सब का सम अगर हम निकाल दें, मतलब ये चारों टाइप का जो भी टर्म्स आ रहे हैं वो सब टर्म्स को ऐड करके अगर हम इस टोटल से निकाल दें, इसका मतलब है जो सम रहेगा that is nothing but the sum of this series जहां पर I is not equals to J is not equals to K. Pretty simple thing. So मेरा जो अभी कम है वो है I have to find out the sum of those terms in this series in which it is following this condition, this condition, this condition and this condition. Now, one thing for sure, if you look at very carefully, I is equals to J, I is equals to J, not equals to K, I is not equals to K equals to J, and I is not equals to J is equals to K. These three are symmetric because the function that is given to us is symmetric. सिमेट्रिक कैसे चेक करते हैं हम लोग? I का जगह में J, in place of J you put K, and if you interchange those variables, the value of the function remains same. So in this case, ये तीनों को निकालने का कोई जरूरत नहीं है, हम सिर्फ इसके अंदर एक को निकालेंगे, and it will be identical for the other two. Are you getting my point? So हम क्या करेंगे, किसी एक का, मानो I is equals to J equals to K, I will try to find out the sum of all terms in that series in which your I is equals to J is not equals to K. The moment I got that, it will be same as when I is not equals to K is equals to J, or it will be I not equals to J equals to K. They will be same because the function is symmetric, as I told you right now. So actually यहाँ पर मुझे, हम जो देख रहे हैं अभी, जो नजर में आ रहा है वो है, मुझे सिर्फ दो केस कंसीडर करना है यहां पर. क्या क्या? नंबर 1, आई विल कंसीडर when I becomes J is equals to K. This is case 1. So in this case, the given sigma will become I is equals to 0 to infinity 1 by 3 to the power 3i, right? Because it is 3 to the power I into 3 to the power j into 3 to the power k. As you have considered I equals to j equals to k, so this term will become 1 by 3 to the power I plus I plus I, that is 1 by 3 to the power 3i. So if I put the values of I, we are going to have 1 plus 1 by 3 cube, 1 by 3 to the power 6, 1 by 3 to the power 9, and this thing goes on. So what will be the sum? It is again an infinite GP series. So 1a divided by 1 minus r. So it is coming like 1 by 27 minus 1, और ऊपर में चला जाएगा 27, So it's coming like 27 over 26, right? So 27 over 26, ये जो सम आया, ये किस टर्म का सम आया? वो टर्म का सम आया जिसमें I, J and K all are equal. Okay, so now let us consider case 2, which is our I is equals to J is not equals to K. So the given sigma will become sigma sigma. I starts from 0 to infinity. K also starts from 0 to infinity. 1 by 3 to the power 2i into 3 to the power k. Because here I and j are equal. Now इसका अगर हम सम निकाल दे, इसका मतलब क्या हुआ? किस टाइप ऑफ टर्म्स का तुम सम निकाल रहे हो? You are trying to find out the sum of those terms in which your I and j are equal but not equals to k. Now if you give a keen view on this, you will find that there are two cases here. I is not equals to k, it has two cases. Number one, your I can be less than k, that can be one case. And another one will be k is less than I. Both these cases, in both these cases, your I and k are not equal. Okay, so let me just try to find out first thing that I is less than k. So your sigma becomes I'm not writing the right boundary for k because it is tending towards infinity. So it becomes actually 3 to the power 2i into 3 to the power k. Now when I is 1, इसका sum क्या होगा? When I is 1, it's basically 1, but your k will start from, when I is 0, your k will start from 1. So it will be 1 by 3 square, 1 by 3 cube, and this thing goes on. Plus, when I is 1, it is 3 square. Now k will start from 2. So it will be 1 by 3 square, 1 by 3 cube, and this thing goes on till infinity. Then when I is 2, we are having, and k will start from 3. So it's 1 by 3 cube, 1 by 3 to the power 4, and this thing goes on, right? And this thing goes till infinity. Now we can see that every term in the bracket is in GP, infinite GP. So we can use the summation formula for infinite GP to get its answer. It will be 1 into A by 1 minus R, because the common ratio is 1/3 here, plus 1 by 3 square, 1 by 3 square divided by 1 minus 1 over 3, 1 by 3 to the power 4, 1 by 3 cube divided by 1 by 3, and this thing goes on. So we are having basically what? 1/3, it's 3 by 2, plus 1 by 3 square, 1 by 3 square, 3 by 2, 1 by 3 to the power 4 into 1 by 3 cube into 3 by 2, and this thing goes on till infinity. Now if I take 1 by 3 into 3 by 2 common, so we are left with 1 plus 1 by 3 cube, 1 by 3 to the power 6, and this thing goes on till infinity, right? Again, this is a GP series, infinite GP. This I can cancel. So outside we are having half, and inside we are having A divided by 1 minus R. So we are having half into 3 cube divided by 3 cube minus 1. So which gives us 1 by 2, 27 over 26, right? So we are getting like 27 over 52. Yes or no? So this is the sum of those terms in the series in which your I is less than K. So now I have to consider the second case where your K is less than I. So let me consider that case also. So in that case, your K will start from 0, less than I, and I is again going till infinity, and the given series is 1 by 3 to the power 2i into 3 to the power k. Okay? So let us find the sum of this terms of that series, which is equals to K will start from 0. So if K is 0, it will become 1, and your I is starting from 1. So it will be 1 by 3 square, 1 by 3 to the power 4, 1 by 3 to the power 6, and this thing goes on. Plus, this thing goes on actually. Then plus, now K is taking the value 1. So it is 1/3. And I is taking the value, I will start taking the value from 2. So it will be 1 by 3 to the power 4 plus 1 by 3 to the power 6. This thing goes on till infinity. Now K will take the value 2. So it will be 1 over 3 square, and I will start taking the value from 3. So it will be 6, 8, and this thing goes on till infinity, plus this thing goes on till infinity, right? So again we are having all the terms in the given bracket, they are in GP, infinite GP. So I will add the summation formula. It gives us A divided by 1 minus R, A divided by 1 minus R. R is here 3 square, right? In this case also 1 over 3 square. Again, this is 1 over 3 to the power 6 divided by 1 minus 1 by 3 square, and this thing goes on till infinity. So we are having actually 1 over 3 square into 3 square over 8 plus 1 over 3 into 9 over 8. Again 9 over 8, and this thing goes on. So let me take 1 by 3 square into 9 over 8 common. So we are left with 1 plus 1 by 3 cube, 1 by 3 to the power 6, and this thing goes on till infinity. Again, this is in GP. 9 goes off, so it is 1 over 8 into A by 1 minus R. So 1 over 8 into 27 over 26, right? 27 over 26. So we are having 27 divided by this. So we are getting 27 over 208. So this 27 over 208, these are the sum of those terms in which your K is less than I And 27 over 52, this is the sum of those terms in the series in which your I is less than k. And if you combine these two, then we will say these two, that is, this one, this sum and this sum is basically the sum of those terms in the series in which your I is equals to j, your I is equals to j, but not equals to k. So what is the sum of those terms in which your I is equals to j is not equals to k? It will be 27 over 52 plus 27 over 208. So if I take 27 common and let us take the LCM 208. So we are having this thing as 4 plus 1. So we are having 27 into 5 divided by 208. That is 135 divided by 208. Right? So this is the sum when your I is equals to j is not equals to k. And as I have mentioned previously, this sum will be identical for these two also. Right? Therefore, the total sum of those terms in which I is equals to j not equals to k, that is 2 are equal and 1 is not equal, is nothing but 3 times the answer that we got here is 135 by 208. 3 times 135 over 208. So that becomes how much? This will be 405 by 208. Correct? 405 by 208. This is for the sum of all those numbers in which 2 of them are equal but 1 is not equal. And when 3 are equal, the sum is 27 over 26. Therefore, sum of all those terms in which I is equals to j equals to k or these 3 conditions fulfills is nothing but 405 by 208. Let me write it here. 405 by 208 plus, when they are equal, their sum is 27 over 26. 27 over 26. So let me take LCM. It's 208, 405 plus 216. Right? So it is coming like 621 by 208. Therefore, the sum of the numbers where I is not equals to j is not equals to k will be what? Can you please tell me? What was the total sum when there was no restriction? It was 27 over 8. It was 27 over 8. So 27 over 8 minus 621 by 208. So this gives us the sum of those numbers in the given series where your I is not equals to j is not equals to k. So if I take the LCM, so it will give us 208 and we are having here as 26. 26 into 27 gives us how much? 2, right? 702 minus 621 divided by 208. Now 702 minus 621, that gives us 1 and this is 8. So your final answer will be 81 over 208. Is it clear to all of you? So what I have done first is, when they have asked me to find out the sum of this series when the restriction is I is not equals to j is not equals to k, what I have done, first I got the sum of all the terms in that series simply by ignoring any of its restriction. And we got the sum, and there we saw that there are 5 cases which are involved in this sum. 5 cases of the numbers which are involved in this series, that are I is equals to j equals to k, that can be one type of numbers in that series. I is equals to j not equals to k, and I is not equals to k equals to j, and I is not equals to j equals to, means two are not equal, one is equal. And then we have considered that three are not equal. So we have to find out the sum of those numbers in which your I, j and k are not equal. So what we have done, we have simply subtracted the sum of those numbers that we got from the first 1, 2, 3, 4 conditions. We got that sum and we have subtracted that sum from the total to get the sum of those numbers in this series in which your I, j, k are not equals to each other. Is it clear to all of you?